Okay, welcome back. So in this video we're looking at 2b, which we have a system of linear equations with three variables. And so this is in the chapter 5 review, so you could use chapter 6 stuff and set up a matrix and row reduce it. I'm going to do it kind of the chapter 5 way where we don't have matrices yet. But essentially what you would do here with this system of equations is you want to eliminate one of the variables from two equations. So I'm just going to eliminate x, we'll say. Okay. So I'm going to maybe use this middle one because it has a 1 in front of the x. I'll get rid of the x's here and I'll get rid of the x's there. So I'm going to do, I'm going to take this one, and first, to get rid of the x's on that one, I'm going to times it by 3. Okay, so I get 3x plus 6y plus 3z is 12. And I'm adding that to negative 3x plus 4y minus z is negative 4. Okay, so we're just adding these together to cancel out the x's, so we get 10y plus 2z is 8. Okay, so that's us getting rid of the x's in the first equation. Okay, so now to get rid of the x's in that third equation, I'm going to take the first equation, I'm going to times it by 12. So I get 12x plus 24y plus 12z is 48. Okay, so I'm again timesing that middle equation by 12, and we're going to add it to negative 12x plus 16y minus 4z is negative 16. Those are getting to be big numbers. Add them together, the x's cancel out. 30, 40y. Oop. Can't really see that. That's 40y. Okay. And then 12z minus 4z is 8z is equal to 48 minus 16, that's 32. Okay, so we were able to eliminate the x out of two equations, and really the system of equations we're left with after doing that is the equation we used to get rid of the x's was this x plus 2y plus z is 4, okay? And then the other two equations we ended up with were 10y plus 2z is 8, and then 40y plus 8z is 32. Okay, so why I'm keeping this one, I mean really you could keep any of these three for the top one, but this one was just a nice one to use. And technically what I was doing here is I was doing 3 times this one plus this one and 12 times this one plus this one. So if you kind of think back to matrices, what I'm doing is 3 times this row plus that row and 12 times this row plus that row, right? But this row, when you do that, stays the same. So I'm just going to keep that one the same. Okay? Now, with this, you will notice that, from here, normally as you're solving these, you just kind of focus in on these two equations right here. Okay, those two equations right there are what you focus on, and then you try and solve for y and z, this is now a system of two equations with two variables. Now you'll notice when you look at this, these two equations are just multiples of each other. If you times this one by 4, right? 4 times 10 is 40. 2 times 4 is 8. And 4 times 8 is 32. So these two equations are actually the exact same equation. And if I eliminated like y in these equations, I would just get, when I do that, I would get 0 equals 0. These two are the exact same line. Okay? So we don't need this bottom one either, because those two were the same thing, right? One was just a scalar multiple of the other. Okay, so now we have a system of two equations with three variables. And so what we want to do here is we want to write the variables in terms of z. Okay, so what I'm going to do in here is I'm going to solve for x and y in terms of z, so that I can write my general solution, because there will be infinitely many solutions to this. So let's start with y here, because this equation just has y's and z's in it, so let's solve for y. So I'm going to subtract the 2z over, so we get 10y is 8 minus 2z, and then we're going to divide by 10. So we get 8 minus 2z divided by 10. That's our y. Okay? So I can pick any z that I want, and as long as y is this, just plug that z in, I will get something that will work in this equation. Okay? Now for this top equation, once I have z, once I can pick any z that I want, that will fix what y is. Y is given by this equation, right? And so then x will also be determined when I plug those two in. So what I'm going to do is, to make it simpler, I'm going to plug in this y so that I only have x's and z's in this equation, and then I'll solve for x. So we get 2 times 8 minus 2z over 10, just plugging that in for y, plus z is 4. So we get x, well, 2 divided by 10 is 1 over 5, so we've got 8 minus 2z over 5, and then plus z is 4. And then you could simplify this a little bit. It's gonna be a pain because of fractions. Okay, well, so to add these fractions together, we need a common denominator. So I need a 5 down there, but I can't just do that. I've also got to times the top by 5. So I'm going to put 5z there. Okay. Then when I add these two, I get x plus, well, negative 2z plus 5z is 3z. So we get 8 plus 3z over 5 equals 4. Okay, we're running out of space, so I guess I'll get us a new thingy. Okay. And then I'm going to solve for x. So we just subtract this stuff over to the other side. So x is 4 minus 8 plus 3z over 5. Okay? And then if you really want to simplify this, you could like make a common denominator with the 5 on the 4, so that 4 times 5 is 20 divided by 5, right? Okay. So distribute in this negative on both things here. Bring that in on all of that. And so 20 minus 8 is 12. So we get like 12 fifths and then minus 3z. So our answer here, we now have an equation for x and y in terms of z, right? And our answers for this are points, right? X, y, and z. So what you do is you just take the equation for x and put that into your point, and then the equation for y, and then z is just equal to z. You can pick any z that you want and plug it in to this point and get a solution for this system. Okay? So that's an example of where you have infinitely many solutions with 3 variables, kind of how you do that.